2, 1, go. Hello everyone from Turin and welcome to Android Heroes Live, the show brought to you by Bluetooth. This is our fifth and last edition of this series. My name is Enrico. I work at the Advento Live team, the producers of DroidCon Italy, Android Heroes, Swift Heroes, and many other tech conferences and events across the world. Advento is Synesthesia's branch for events, and we look after the production of all these events. Today, as I said, is our fifth edition of this Android Heroes Live. We are proud to be supported by Bluetooth in this adventure. We have today another interesting talk for our last episode. So it's a real pleasure for me to welcome Divya Jain, lead Android developer at Bluehole. Hi Divya, how are you today?
I'm great. How are you? Thanks for
I'm
having
good.
me.
Yeah, thank you for joining us today. So you're based in the US, right? So shall I say good morning to you now or?
It is a good morning. Yes, I'm based out of San Francisco.
Okay, interesting, good. Is it sunny as here in Turin or?
It is pretty sunny and warm. Yes, it's
Nice.
the summers are not over yet, I guess.
Yeah, exactly. Same here in Italy. But it's good sometimes. So just
Yeah.
before we get started and we leave the floor to you, I have a question I frequently ask to our speakers, a question for you. How do you feel with this thing of remote presentations? You know, with the COVID thing,
Right.
everything moved online, but we actually had some ideas to go to a digital show before that. So I just wanted to get your thoughts on this. How do you feel as a speaker, pros, cons?
I think it's been great, and I always try and look at the positive sides. Of course, nobody would want the pandemic to have happened at any time, but I think it has given such a great opportunity for developers all across the world to be connected.
Yeah.
I have attended conferences personally before, and that has its own unique positives about it. But I think it's commendable how the community is getting together and adapting to this new world that we are living in. So
Yeah.
I would say it's been great so far.
Yeah. Interesting, as you say, except the pandemic, of course. Yeah.
Right.
And also, it would be super tricky for us to arrange a show like this if you were on the other side of the world. Yeah,
Exactly.
like this
Right.
is
So I think
super.
it's been great connecting together.
Yeah, exactly. Okay, good. So you talking today about Jetpack Compose, right? Clean architecture with Jetpack Compose is the title of your talk.
Yes.
Okay, good. So we're gonna be joined after all by our tech leader here at Synesthesia for some Q&As. But I always
Right.
remember our attendees, they can post their questions in the chat they find beside the video live. So if anyone has any questions, please feel free to ask and we'll make sure we can take them after. So Divya, we're gonna run just a super short intro and then over to you.
Sounds great.
Thank you.
All right. Hi, everyone. My name is Divya. I am an Android enthusiast, have been developing Android apps for over 7 years now. I'm really excited to be here today. And before I start, I would really like to thank all the organizers for giving me this opportunity and really appreciate all of you being here. So, what we are going to talk about today is Jetpack Compose, the new declarative UI toolkit that everybody's been talking about, especially since it released, like production released a couple of months back. What I'll primarily focus on are the Android architecture patterns, its importance, and how the recommended patterns like MVVM transcribes into the Compose paradigm. This hopefully will be helpful to both the people creating new apps with Jetpack Compose, but also for people looking to migrate their existing apps. The Jetpack Compose fundamentally changes the way the UI is constructed in Android. It moves from the imperative way to declarative, making the views immutable and hence basically changing the way the view connects with the state. So we'll talk about all that, emphasizing on how you can still separate the business logic from the compose views and why is it important to still do that and what might be some of the best practices. Now, when it comes to developing apps in Android, over the years, we have seen a lot of changes. Of course, we went from God activities to the era of async tasks to event buses to all the buzzwords like MVVM, MVP, Jetpack, etc. But the core reasoning behind these improvements always remain the we want to develop apps with clean architecture, which means there needs to be a clear separation of concerns. One should be able to individually test these components, which overall makes the entire app easily testable. And a well architected app is maintainable and scalable. You can iteratively add features to it without worrying about breaking the existing system. And so ultimately, you are ensuring that you're building robust and testable apps. Now, yes. So now we're all familiar with the traditional imperative way of building UI by inflating XML, which has a hierarchy of views and view groups laid out in a tree like structure. And as there are state changes as a result of either user interaction or something by the system, the UI hierarchy is updating by directly changing the internal state of the widget. So, for example, if a text for a text view changes, first we will, in some form, do a find view by ID to find the text view in the widget hierarchy, and then call setText method directly on the text view to update its text value. Of course, manually mutating the state comes with its own set of issues. There can be possibly update conflicts. You might be updating the wrong view. The view might exist in multiple places and you might forget to update it at one place. But all these issues are resolved with Compose or the declarative UI model in general because the view becomes immutable and sort of stateless. We are no longer editing any XML layouts or creating UI widgets directly. Instead, we call composable functions defining what we want, and Compose compiler does its job of rendering these on the screen. And whenever the app state changes, the entire UI is regenerated from scratch. Now, let's look at a very simple example. Now, this here is a composable function that lays out two widgets, a text label and an input text field, together in a vertical column. Now, this code explains a lot of things. So, as I mentioned before, A, there is no XML inflation. Instead, whatever UI you are drawing is laid out in terms of these composable functions with modifiers. Now, the composable annotation is what tells the compiler that this function is just to convert data to UI. Second, you can pass in data to this function, and the function would emit UI according to the data. So, this function text sample could easily have taken the text value as a string parameter and updated the value of the text label correspondingly. Also, the composable functions have their own UI hierarchy. So the text sample here calls the text and the text field composables. Now, in this particular scenario, this function is really not stateless. It holds the text value that is entered in the input text field to a local state variable, and that variable is used to update the value of the label. Now, in case anybody is wondering what remember savable is here, there are two key composable functions for state. There is remember and remember savable. Essentially, what they do is store a single object in memory and persist it across composition and recomposition. Now, the difference between the two is that remember persists it only across recomposition, but remember savable persists it even across configuration change by saving it in a bundle. But again, when the user inputs a different value, the thing to remember is we are not doing the set text manually to the text label. Instead, compose actually redraws the whole text sample column again and also intelligently knows to update the text on the label since that's the only value that has changed. Now, before we proceed, we have been using these terms composition and recomposition. So let's formally define them for everybody's benefit. Now, composition is the initial creation of the UI, which is described by the composable functions. And then there is recomposition, which is basically updating the composable to say, hey, the data supplied to you has changed and you need to redraw yourself with the updated data. Of course, redrawing the UI every time there is a data change sounds super expensive for the resources. But here's where Jetpack Compose recomposition is done in an intelligent way, so that only the part of the UI that is affected by the new data is redrawn instead of the whole UI hierarchy being regenerated. Now, this provides several benefits. The functions are fast and, most importantly, idempotent, which means you can call the function multiple times with the same value and the function would behave exactly the same. And also, it is side effect free since there is no manual manipulation of state. So the chances of errors are almost negligible. So now we know how Jetpack Compose concept fundamentally is different than the traditional imperative way of developing UI that we are used to. So now let's ask ourselves a couple of questions about this particular example. Now, do you think we can call this a pure UI or just a view? Not really, because the composable here holds its own state. Now, do you think there are separation of concerns here? Again, not really, because the composable is actually tightly coupled with the way the state is stored. And if you would want to individually test this, it's again not possible. So all the answers are no, because here we have sort of introduced business logic and coupled it in the UI code by maintaining the value that is entered in the text field to a local state variable and updating the value of the text all together in the same function. Now, it's such a simple example, it might not make much of a difference. But as this example grows into even slightly complex screens, we absolutely need to extract any business logic to a separate component and ensure that the views remain as dumb as possible. Just to their basic idea should be to emit the UI based on the data that is passed to it. So that's what we are going to focus on today, is how to build these composable functions from a clean architecture perspective. And we'll eventually realize that Jetpack Compose, the way it is written or built, actually itself assists and works very well with the recommended architecture components. All right, so how can we decouple state from a composable function? Now, there is a programmatical pattern called state hoisting, which is basically extracting the state out of the composable and instead move it to the caller of the composable. And pass the value of the state to the composable as an immutable parameter, and also expose functions as parameters to represent user events like any value change, etc. Now, this pattern is important because A, it ensures that there is a single source of truth, one single place where the state is coming from, which means less bugs and consistency. Now, how the caller handles or modifies the state is again not the composable's concern. So, business logic is abstracted away and encapsulated. And then multiple composables can use this hoisted state since they are unable to manipulate them. So, it can be reused multiple times. So, now let's apply this state hoisting to the text example that we looked at before. Now, as seen here, we extracted the state variable text value out of the text sample into the text sample caller function. And instead, text sample receives the value as an immutable parameter. Also, for the text field to tell that the value typed in it has changed, we pass a lambda function as a parameter on value changed, which handles state in the caller function. So basically, state comes as immutable to the text sample here. And if there is a user event for state change, like the text field value change here, it notifies the handler through the passed function. Now, this way, the composable text sample is completely stateless and dumb, since it's just reacting to the state change and intelligently and efficiently composing and recomposing when the data changes. Now, most importantly, text sample now becomes more reusable and decoupled from state, so it's easily testable. Now, the text value to this composable can actually come from anywhere, either a view model or a local state value of the calling function. And also, you can invoke this composable function from multiple callers, and these invocations will be independent of each other and side effect free. So now all that we've talked about here alludes to a design pattern that is very helpful and basically essential to keep in mind when architecting your Compose apps. Now, this pattern is called unidirectional data flow. UDF is a pattern where, as you can see here, state flows to the UI from the part of the app that is storing and changing the state, and the events generated from the UI flows up to the view model, which basically means that you are decoupling the state entirely from the UI, and UI is only responsible for displaying the state. Again, that ensures the ability to test each of these in isolation. It also ensures consistency in UI and ensuring that the view model is the single source of truth and only the one responsible for manipulating the state. Now, before we talk about architecture in detail, there are certain things that we need to remember about Compose, which will aid us in making decisions around the importance of separating business logic and state from composable functions. Now, we already know that composable functions build UI hierarchy by calling other composable functions. So let's say we have a master composable function calling three composable functions inside it, A, B, and C. Now, these composable functions can be executed in any order and not necessarily in the way that they appear in code, because that's just how Compose works. It will determine itself what the priority might be and execute them in some random in an accordingly appropriate fashion. But why is this important? Again, you want these composable functions to be as self sufficient as possible and not carrying out business logic in them. Or you don't want them to mutate some global variable or be dependent on some value which is mutated by some other composable functions. Again, Compose might want to efficiently carry out the multiple composable functions, so it might execute them at the same time parallelly And again, we don't want to have any side effects. It is also possible that the invocation of the composable functions is on a different thread. And so, again, you don't want them to be modifying some variable to prevent any unintended outcomes. The same thing goes for recomposition and compose as well. It does intelligent recomposition, which means it will redraw the whole UI, but only update the parts for which some state has changed. And if the parameters have changed again, even before the recomposition finishes, it might just suspend the original recomposition and start again. So, again, the important thing to emphasize is that you do not want any side effects during the recomposition, which might lead to inconsistent app state. Or let's say there is an animation playing, some value is constantly getting updated. So, recomposition might be happening for every frame or might not be happening. So you don't want a janky UI due to some heavy operation happening inside this composable function, right? So ultimately, the goal is that composable functions should be idempotent and side effect free, which basically means they should be logic free. Now, let's talk about the actual stakeholder. Now, some of us are already familiar with the recommended Android architecture components and the famous MVVM architecture pattern. Let's do a quick refresher. Now, the model here is the holder of the data. This can be from an API, from local database, anything. Now, the view model interacts with the model to get the necessary data and update it as well whenever necessary. The view model exposes this data as a data stream of state, basically as an observable. And the view in return can subscribe or observe this exposed data stream. And whenever there is a change in the state, will render itself or update itself. Now, on the other hand, whenever there is a user interaction, for example, a button click or a text input change, the view would pass that event to the view model and ask the view model to take the necessary action. Now, in this case, the view model updates the model if need be, updates the state, and then dispatches it to the data stream which the view is subscribing to. Also, we know view models survive configuration changes and are lifecycle aware. So we don't have to worry about manually handling the lifecycle of the activity or the fragment. Now, because of all these properties and benefits, view model becomes the natural choice for stakeholders for the composable functions also that we are talking about. So now let's go back to our text field example and modify the calling composable function and see how we can use a view model as a text view stakeholder. Now, as you see here, the text value live data holds the state, which is observed by the UI, which is if you correspond it to the state flowing down to the UI in the UDF pattern. And then on text value changed is the event that the UI can invoke corresponding to the event flowing up from the UI. So that's for the view model part. And then we have the caller composable here, which is the text sample caller, which accepts this view model as a parameter. Now, again, couple of things to note here. The view model automatically follows the life cycle of the activity or the fragment that calls this composable function. So again, you don't have to worry about dealing with the lifecycle shenanigans yourself. Observe as state, which is what you see here, returns the state from the mu model in a form that triggers a recomposition of the composable that reads the state whenever it changes. So this is the function that transforms the state from the view model that can be consumed by any composable function. And of course, with this kind of architecture in Compose, you retain all the benefits that comes with the MVVM pattern. There is a separation of concerns. You can test each component in isolation. It is scalable, maintainable, easily readable, and it makes integrating Jetpack Compose with your existing apps super easy and convenient. Because if your app already follows the MVVM architecture pattern, all you need to do is change the UI view by view into composable functions and pass the right state as parameters from the view model. Now, apart from live data, Jetpack Compose also provides extension and support for Kotlin Stateflow and RxJava. So here we are using the same text field example where the view model exposes the text value as a state flow. And if the on text value change is called, the new value is emitted. And in the composable, we consume this stream as collect as state. Now that's the only difference between live data and stateflow as far as compose goes. Now, again, a couple of things to note here. Compose automatically recomposes from reading these kind of state objects like stateflow, which is why when we use something like live data, we convert it first to a state object by calling observe as state before reading the value in a composable, so intelligent recomposition can be triggered. Another thing is one cannot use mutable objects as state in compose like an array list or a mutable list. So for the same purpose, these mutable objects are not observable, and so compose will have no way to know that the state and state has and recompose, which means it will lead to state discrepancies in the app. So the conclusion is that always use observable state for deriving compose functions. Now let's increase the complexity and actually look into an app itself to see how the architecture, view model, and Jetpack Compose comes together in a real example. Now, this screenshot is from the first round of dev challenge that I did for Jetpack Compose. Adopt Happily, which you see here, is an app for finding dogs in your neighborhood that are up for adoption. Now, the data is hard coded here, and I have a link to my GitHub repository where the whole code is available in case anybody is curious. So, first, looking at the view model, you see here that we have a repository, which is where the view model is getting the data from. Now, in this case, it's a list of dogs along with attributes like dog name, image URL, breed, etc. Now, if you see here, view model exposes this data through a live data dogs list, which can be observed as state by any view, composable or not. Also, tomorrow, if we want to add more requirements, for example, add features like ability to favorite some dogs, etc., all we need to do is update the view model to add that action in response to the event we are trying to add without without worrying about breaking anything that already exists. And now looking into the UI of the dogs listing screen, which is built entirely in Jetpack Compose, and observing the dog list exposed by the view model as a state, subscribing to it so that whenever the dog list changes for whatever reason, intelligent recomposition is carried out and the parts which needs updating are updated. So, for example, let's say image for one of the dogs is updated on the back end, and our view model gets to know about the update. The view model will update the dog list, which in turn lets the composable know that dog list has changed. And in the recomposition, only the image URL will be updated to reflect the new image immediately. Best part about this, again, all our logic in the view model is abstracted and testable. Now, any expensive operation can be offloaded to background coroutines. And conclusively, Jetpack Compose in this manner is again becomes easier to integrate with your existing app if it's built with the recommended MVVM architecture. Because mostly, again, all that you need to do is switch the UI and the view model logic remains intact. Now, before I conclude, I do want to talk a little bit about the other architecture patterns that we know of and if and how they transcribe into the compose paradigm. So let's talk about MVP, which is the model view presenter. Now, just to refresh, the MVP pattern separates data model from a view through a presenter. Now, the model is the holder of the data as usual. The view represents the UI, and the presenter contains the business logic. But it's different from the MVVM pattern in the sense that presenter actually contains the reference to the view that is injected as an interface and tells the view when to update. So it's a bidirectional flow of data between the presenter and the view. Now, because of this kind of coupling, it is nearly impossible to implement Jetpack Compose with an MVP architecture. And the biggest reason is that composable functions do not have a return value. So you have nothing to pass to the presenter for as the view reference. Now, one may ask, why do compose functions do not return anything? The simple answer is that that's what the declarative paradigm is. The functions simply describe the desired screen state and actually do not construct any UI widgets to return. Hence, it is best advised that if you have an MVP architecture in your app, the steps would be to first convert it to a unidirectional data flow based pattern and then integrate Jetpack Compose into it. Now, another popular architecture these days for Android is MVI, which is model view intent. Now, this architecture is fairly different from the way other patterns work. So, let's look into it a little bit. So, what does MVI stand for? There's again the model. Now, unlike the other patterns where model usually means a data holder, here it also represents the state, and that too an immutable state. So there is a direct unidirectional data flow. Now, the view are again your user activities and fragments, which provides the ability for the user to interact. And then there is an intent, which basically represents an intent to do something. Has events which leads to intends to mutate state, and model transforms itself to a new state instead of mutating the current one based on action, and then the view re-renders itself according to the new state. Now, because the model is immutable, it becomes the of the overall state of the app. So it, again, with an architecture pattern like MVI, it makes it super easy to handle state in your app because it's all in one single place. And then there is also thread safety because models cannot be mutated from multiple threads, which means there are no side effects. So now when it comes to compose, we already have seen how MVVM did it. Since view models are usually great state holders, our needs of a clean architecture are usually satisfied. But when you talk about really complex applications, there is a slight caveat of view models having multiple entry points when there is excessive interaction between the view model and the view. And the view model itself might become complex to be able to scale and maintain. And so, if you think about it with MVI, you basically still get all the benefits like a UDF pattern, immutable state, and view rendering, which is derived from the state. So, the new question to think about is, why not combine MVVM with MVI, take the best parts, and use them in conjunction to create even cleaner applications? So in this case, the view model is still in charge of mutating and handling the state to which the composable view is reacting to, but we also borrow some concepts from MVI to reap its benefit. Now, I personally haven't delved into this architecture much, but there is a great article that I read about the same, and a big shout out to this blog post. I have included a link here, and I personally do hope to dig deeper into this architecture sometime soon, but I highly recommend to check it out. All right, so to summarize everything, we know that the UI in Compose is immutable. Once it is drawn, there is no way to update it. Instead, what you control is the state of the UI, because once the state changes, the compose recomposes itself and updates the parts that have changed. So composable functions accepts only state and exposes events. Now, because of this, a unidirectional data flow pattern integrates seamlessly with Jetpack Compose. The overall idea is to use an architecture pattern like MVVM or even with MVI to decouple the UI that displays the state from the view model that stores and changes the state. Now, this, again, reiterating the benefits, provides us with a lot of pros. There is separation of concerns, there is testability, there is state encapsulation, where view model becomes the single source of truth for the state, preventing any inconsistencies. You're also ensuring UI consistency since Compose works smoothly with live data or state flow, so the UI changes are reflected immediately as state changes. There is reusability, and last but not the least, it's a super easy integration with existing apps, especially if they are already using the MVVM architecture pattern. All right, with that, I conclude my talk. I am happy to take questions now, but you can also find me on Twitter or email me at the email ID that I have here. I'm always ready for a technical chat and would be happy to happy to have a technical chat with anybody anytime. Thank you so much.
Hi again, Divya. Thank you for your talk. It was interesting, and I think it looked straight to the point, even if it's not my topic. It sounded really clear and and spot on. So, as I said before, I'm going to ask now our technical leader for Android, Marco Porcaro from Synesthesia, to join us. Ciao, Marco. How are you?
Ciao Enrico, I'm fine, thanks. Hi Divya.
Hi, Marco.
Thank you
Nice to
for
meet
your
you.
talk.
Okay, Marco, I guess
Enrico was right, it was super clear and straight to the point.
Thank you.
Good. Marco, I think while we wait to see if there is any questions from the public, I think you have something for Divya to ask. I leave it to you guys, and I'll be back in a while.
Okay, thanks Enrico. Yes, I have some question for you. There are curiosity. The first one is that you showed us two options to expose states from the view model to the view, live data and state flows. What is your favorite between the two, and why do you use one instead of the other?
I think so. So from my perspective, I have used live data for the longest time, but so for me, I think since I've used live data for the longest time, it's very familiar and it's something easy to integrate with. But now I've been delving a lot more into state flow, and I think it's becoming my new favorite, but I'm still not 100% there yet. But state flows definitely does provide in my view does provide a lot of benefits over live data, and it sort of uh, overcomes the shortcomings of live data to even present like the state of data in a more consistent manner, I feel like, which is easily consumable by any view that is subscribing to it. So I believe I'm getting more used to state flows, if that makes sense.
Okay. Okay. Thanks. And are you using Compose in a production app, or are you using it a lot? Did you find some drawbacks on using Compose?
I have been, so till now, I have been using it only in my side projects, but especially with the help of the dev challenges that I did, and um, I've been experimenting with it a lot, I would say, in my side projects. Uh, the I would say, so I would say overall, I have seen a lot of pros, especially if you already have an app that is written, which I just go back to my old apps and try and integrate Compose into them by switching out the UI one by one. And I think the a lot of things a couple of things that it helps me with is a building really great UI with a lot of less boilerplate code. For example, a very simple example is any app that is created these days has a lot of like lists and data to be shown on a list. For a normal way of writing a recycler view, there is a lot of boilerplate code around view holder pattern and adapter and stuff, which but with Jetpack Compose, it's literally a few lines of codes, which makes it super easy to be able to write code much faster. So I believe overall I've seen a lot of pros. I think it is still a learning curve, but I would really like to give a shout out to the community. The number of the large amount of work that everybody's been doing to come up with examples and um, uh, share it with the community has been commendable. So I think the community support has been great, which has been super helpful.
Okay, thank you. And there are some questions from the audience. One Adrian asks, when using a scaffold as main screen, it seems that fragments are no longer used. How would one get view models with fragment-like lifecycle for separate subscreens? And how would you navigate between those screens?
So I'm not 100% sure, but that with I know that Jetpack Compose is slowly becoming compatible with with the Jetpack navigation component, the Jetpack navigation library that allows you to easily navigate between different components. What I would do is I would create a sample app and share it on my Twitter sometime soon, if that is helpful for people out there who have questions
Yes,
around it.
thanks. Because one of my questions was where do you use the navigation from the view models or from from the composable part? Mm, mm,
Right. I will
So,
create a sample app and do my
okay.
research before I answer that. Yeah.
Thank you. And there is another question from Manu that asks if there are any resources that you can advise, so some books or website.
Oh, I don't have a list. I do have a list like saved, which there are a lot of like special GitHubs that I relate to. What I can do is I can actually compile a list of it and add it to my slides before I share it out.
Thanks. It would be
Yes.
great. I have just my last question for you. That is another curiosity. How much compose did you it forced you to rethink on the way that you write your UIs?
That's a great question. Is the question how much did compose re asked me to rethink that makes sense. I think again, as I said before, initially it was a little bit of a learning curve because we are so used to writing the XML way and mutating the state and manually doing everything. So I think overall it has made me think more about the way I'm architecting my app or the way I'm making decisions, because I think the whole idea is to make the UI as much more dumb as possible, if that even makes any sense. And you would also want to, I'm also thinking more about reusability and making sure that even the UI that I'm creating, I'm able to break it down into smaller components which are easily reusable and abstracted away.
Okay,
Mhm.
thank you.
Rimettimi.
Uh,
Okay, guys. Thanks a lot for your questions. Nice to see also the interaction, and I can see both Adrian and Manu, the guys who asked the questions to you, they also said thank you. Interesting, so that's nice to see. Thanks also, Marco, for being with us today.
Thank you.
It's always nice to have support from a technical leader. Divya, you're going to also join us at DroidCon Italy, right? Our main flagship show later in November. I think your talk is on November 11, so it's on the first day. And
Yes.
it's about recycler views, right?
Yes, that is correct.
Okay, any hints, any previews, just to make, people want to follow you on that day?
I think it's all about, so recycler views is one of my other favorite topics, because every app that you see today has a list of data, whether it is social media app or any app that you see, there is just so much data to represent. And so what I would want to do with the talk is go back to the basics and just share what's been happening in the recycler view world. So just doing a deep dive into it.
Okay,
Nice.
sounds interesting. But Marco, I know we have a lot of topics at DroidCon, so not just this one. So I'm going to invite our audience, of course, to register. I also want to remember our audience that with the ticket you get exclusive access to all our presentations, and this will also be on demand for 3 months after the event, just for ticket holders. So don't forget to get your ticket today at a very fair price. I want to say thank you again to Divya for being with us today with this interesting talk, and for Marco also for supporting us. So thanks a lot, guys. See you again at DroidCon Italy in less than 1 month.
Thank you.
Thank you so much for having me. Super excited to be here and to be in DroidCon Italy.
Yeah. Bye bye.
Thank you, Divya. Bye.
Ciao.
Thanks. Bye.
Okay, and thank you everyone for following us today. As I said, this was our last episode of Android Heroes Live, sponsored by Bluetooth. It was a very nice and interesting adventure with our partners of Bluetooth. Just as a reminder, you can see all the shows, and also they will be published on YouTube in a week or so from today. It was great having all of you on board, and again, DroidCon Italy is our main show, taking place 11 and 12 of November. We can't wait to welcome you there, and thanks a lot, and bye bye.